Hello everyone. This presentation is towards the peer-graded assignment for human factors in AI course by Duke University. And the project which I am presenting to you all is known as Finding Fabry. So what's the issue? Fabry disease is a life-threatening rare genetic disease that slowly destroys vital organs like heart. Doctors are not able to diagnose this disease efficiently. Currently, it takes a couple of decades to diagnose this disease, and genetic studies show that only one-fourth of patients across the world actually ever get diagnosed. There are effective medicines to manage Fabry disease, but delay in treatment keeps making medicine ineffective and keeps increasing the suffering, leading to early death. So the question is, can we use artificial intelligence to diagnose Fabry disease? So for this project, we will be evaluating four topics. The first is task analysis for this particular project. Two is user experience design. Third is privacy considerations. And the fourth is the ethical considerations for this project. So let's do a task analysis. What happens when a Fabry disease patient visits a doctor? So Fabry disease patient typically comes to a cardiologist who then performs something called as electrocardiogram, ECG. And after that, various other evaluations are done. Now, based on all these evaluations, the doctor is generally confused because he then can think of a huge list of differential diagnoses. The problem is Fabry disease comes with so many signs and symptoms which are similar to so many other diseases. And because of this, the doctor gives provisional diagnosis of commonly occurring ones and not suspecting Fabry disease. And decades pass, misdiagnosing the patient with one differential diagnosis with another and prescribing all sorts of incorrect treatment because he's actually a patient of Fabry disease. Finally, after decades of such kind of misdiagnosis and mistreatment, the Fabry disease is suspected by the doctor if the patient is lucky. And then the doctor would perform genetic tests and enzyme analysis, and the confirmation would come that it's Fabry disease. Post this, the treatment starts. But then so much amount of time has passed, the damage done by the disease is kind of permanent and it keeps on progressing. So that's the journey of a patient going through multiple diagnosis and multiple treatment, not really getting diagnosed with Fabry disease. So based on this task analysis, can we identify a potential solution? All patients suffering from Fabry disease have changes in the heart that can be actually picked up by ECG. Unfortunately, it is extremely difficult, even for a trained human eye, to detect ECG patterns that are suggestive of Fabry disease diagnosis. And the hope is that using artificial intelligence, we can pick up patterns and learn, which might be impossible for even a well-trained human eye. Now, if we are developing such an AI model for analyzing ECG and diagnosing Fabry disease, what should be the user experience? So let's talk about the user experience design. The proposed solution concept is an artificial intelligence sourced code that will be integrated into ECG machines. Currently, across the world, all ECG machines run a code that can read ECGs and automatically tell if there is an abnormality in the axis or the voltage of the ECG. With this newly inserted code, the ECG machine will red flag the ECG reading with a note of suspected Fabry disease. So for example, a patient has got Fabry disease, but the doctor doesn't know about it and does an ECG. This AI model should be able to insert a note into that particular ECG recording that this patient might be suffering from Fabry disease. All right. And this red flagging will then trigger the physician to conduct genetic testing and enzyme analysis, which will either confirm or rule out diagnosis of Fabry disease. And this confirmation will then be fed into the UI of the machine, thus allowing the AI algorithm to retrain itself continuously, thus improving the predictive power. Now, how will we go ahead with the validating of the concept solution? We will create a model concept based on heuristics and insert the corresponding code on ECG machines at few cardiology clinics. We will evaluate how easy and intuitive the process is and collect feedback from the users to improve any part. We will version each iteration and seek feedback from data scientists and machine learning engineers to evaluate feasibility of new or altered features generated by the users. The final version, which gives best response from the users and deemed feasible by internal experts, will be the end design that will be aimed while building the final model. Now let's talk about potential risks in production of such kind of model. One is there can be inefficiency due to limited data. We know that Fabry disease is a rare disease and there will be limited data on which model will be trained. This itself can lead to an inefficient model at the start, but we envisage a continuously self-training model. This we hope will improve the model and the inefficiency will keep coming down as more and more patients keep flowing into the system. The another potential risk can be because of concept drift. As the diagnosis rates improve and patients start getting treated, the treatment itself might change the ECG parameters linked to Fabry disease, leading to substantial concept drift. But this part can be resolved by putting treatment status and duration of treatment as labels. Now let's come to the privacy considerations. So the first thing is that for this particular project, no personal identifiers will be collected from any patient. Data collected will be anonymized and aggregated. HIPAA and GDPR laws will be completely complied with. To further ensure compliance with GDPR laws, AWS servers located in Germany will be used to train AI on data coming from European patients. So no data will actually flow from Europe to US, although we are doing the project in US and we want data from all across the world to come in. We will ensure through this particular route that no data from European patients are actually coming into the US. Our model goes to Europe through the AWS servers, gets trained on the data which is available in Europe, and then comes back. Now let's consider the ethical considerations. Is there a potential source of bias? Of course there is. Most of the patients are males due to unique genetics of this particular disease. This might make the model biased against female patients. We hope to keep this bias limited by not using gender as a label for any of the correlations. Finally, let's talk about fairness, accountability, and transparency. We intend to keep the model fair by using only ECG data from as many sources available as possible. We would create accountability by clearly mentioning following. First, the signal coming from the model is just an indication that the patient might be suffering from Fabry disease. This is not the diagnosis. Final diagnosis should be made based fully on clinical parameters by a clinician. This artificial intelligence tool, hence, is just an aid to diagnosis and cannot be used solely for the same. Similarly, no signal for this artificial intelligence model does not mean that there is no Fabry disease. So even if the AI model suggests that the ECG which it is analyzing does not belong to a patient from suffering from Fabry disease, the clinician should be well informed that this might be untrue. And if there are clinical suggestions or his clinical acumen says that this patient might be suffering from Fabry disease, he or she should completely ignore the lack of signal from the model. And we would also be completely transparent by clearly mentioning the algorithm parameters we have used, and we will also be declaring the limitations of the model. With this, I would like to end this presentation. Thank you.